The tools exist: generative design, digital twins, bio-integrated systems. But tools without vision are nothing more than expensive toys. The magic happens when human imagination meets experiences that are yet to be defined. When we stop asking what's next and start asking what if. These are the conversations that reshape life on the water. This is Rethink's Night Out.
We have all heard of the band AC/DC. We know their songs and we recognize the impact that they made on the music industry. But what does their name actually stand for? Well, alternating current and direct current are two ways in which electricity can be transported from power plants to our homes. So, which one is better, AC or DC? This was a prevalent question at the end of the 19th century when the war of currents occurred. On the left, we have Nikola Tesla, who advocated that AC was the way to go. And on the right, we have Thomas Edison, who defended that DC was the best option. This beautiful device that you see in the picture is what we call a transformer. And back then, transformers were the only effective way to control electricity. So, long story short, it was decided that AC was going to be the way to go. Now, cut to the end of the 19th century, we have the introduction of semiconductors. Semiconductors were a huge revolution. They changed the way the world looks to what we know nowadays. It is thanks to semiconductors that we have power electronics and we can connect wind turbines, batteries, and solar panels to our electricity grid. The introduction of semiconductors also unlocked the full potential of direct current. We were able to make systems safer, we improved efficiency by reducing power losses, and we made devices more cost-effective with compact designs that reduced material usage. The Zero sailing yacht allowed us to explore the potential of DC technology in the maritime industry. And look, when you have a goal as ambitious as designing a yacht with these dimensions, relying solely on renewable energies, every bit of energy that you consume matters. So we looked into two main topics. On the one hand, solar panels, and on the other hand, LED lighting. In both cases, we asked ourselves, how can we improve efficiency in these two fields? We analyzed the market, identified shortcomings, and proposed new solutions. Solar panels are not a new technology for vessels. They have been used since the 70s and the 80s, and it's a good fit. Boats are in sunny weather countries, and they have surfaces where panels can be installed. But let's take a look at this next picture. It's a sailing yacht where we have solar panels installed on the rooftop. Now, what is happening? It is surrounded by sails and masts that are casting shadows on it. And we can imagine that this has an impact on the performance of these panels. But how much of an impact does it have? Well, let's take a look at this panel on the left. It's a solar panel, a standard solar panel, which consists of many small rectangles that we call solar cells. These solar cells are connected one after the other in series, forming this snake kind of shape. Now, let's cast a shadow in this solar panel. What happens if a leaf falls on it, for example? Well, you can think of it as a gardening hose. Even if you pinch a gardening hose in a very small spot, the water flow of the entire hose is affected by it, right? So the conclusion is that a very small portion that is shaded can have a great impact on the performance of the panel. So we rolled up our sleeves and started evaluating panels and casting different types of shadows to understand how panels behave. With these conclusions, we came up with a new approach, went to our lab, and developed what we called a micro-maximum power point tracking solution. These are some of the results we collected outside of our lab. And what we did was we placed a solar panel in front of a tree and monitored its output power data throughout the day to see what kind of numbers we got. we saw a significant increment in the performance of the panel under partial shading conditions. And in fact, we decided to write a paper about it that we presented last year at the International Conference of DC Microgrids. You can find it on the IEEE library if you want to read more about it. We wanted to push limits even further. We were able to get some good results with panels, but we asked ourselves, what are other areas in which we can make a difference to minimize consumption in this yacht? And the next logical step seemed to be lighting, LED lighting specifically. Yachts are filled with LED lighting strips. They are on walls, they are on ceilings, they are on the floor, they are surrounding furniture everywhere. So they actually account for a significant amount of the energy consumption on the vessel. So we followed a similar procedure in which we analyzed existing solutions and came up with our own prototype. Here you can see our own solution. This was actually tested at Fripak, and we were very pleased to see that in order to output the same amount of light as we originally did with the original LED strip, we needed 2.5 times less power. Direct current technology is, of course, not only limited to LED strips or solar panels. It can also give an answer to worldwide solutions that or worldwide challenges that we're facing nowadays, such as net congestion. This is a project where we have local generation and storage to help alleviate local net congestion. Lastly, I included a picture of the first ever project that I did while I was a student in the TU Delft, because there I analyzed how DC can facilitate energy access to rural areas in developing countries. Because if we had to do it all over again, we would take a different approach. So far, the maritime industry has followed the current of the seas, but now we have a new current that's revolutionary, and that is the direct current. Thank you very much for your time.